Professor Belfrost's science class is back.
Hi, welcome back to this channel, and today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Hi, welcome back, and today we'll discuss several exam problems as usual. Okay, so I've prepared physics, chemistry, and mathematics problem. Each of them is one. Okay, let's start. This is our uh, problem that we'll discuss. We start from math. Okay, can you see it? I think it's clear. Okay, so yeah, number one is math. Okay, so yeah, we have two functions. Yeah, this is the line equation. Okay, where 2x plus y minus z equals 3 and x plus 2y plus z equals 2 to be two planes, not two lines. Okay, because there are three variables, it means it's three-dimensional, two planes. And then which one of the following statements is sort of true? Okay, so we have A, B, C, and D. Let's see. Okay, so line of intersection. Actually, there's a formula, okay, that you need to know to find a line of intersection. Okay, so the direction of the line intersection is given by the cross product of these two vector, the n1 and the n2. So you can create it in a matrix form as shown in this, yeah, in the slide. Okay, and you arrange them as it should be. So you only take this 1, 2, 3, the constant, you draw it first. You don't need it in this calculation. So 2, 1 minus 1, 1, 2, 1. Okay, so how to calculate this is very easy. For I is just cross it like this. 1, 1 minus minus 1, 2 is 3. Okay, for minus j, it is 2, 1 minus minus 1, it is minus 3. Okay, for k, it is 2, 2 minus 1 is 3, 2. Okay, so the ratio is 3 by minus 3 by 3, right? Which is 1 by minus 1, 1. So the option is 1, 2 minus 1, so it's wrong. How about line 3x is 4 by 9 equals 1 minus 3y over 9 equals z over 3 is perpendicular. Let's see. So actually, you need to make this denominator to be the same um, number at first. So you can see it clearly now. You can compare the numerator. Okay, and you can clearly see that all of this, okay, is parallel, okay, to the line of intersection of P1 and P2. Why? Okay, can you find out? This is the line of intersection of the P1 and P2, and this is the formula that the line that is said to be parallel to the intersection of P1 and P2. I want you to find the answer because it is actually very straightforward. Okay, this is the I, this is J, this is K. Why it's said to be a parallel? Okay, please drop your comment. Please drop your answer. I mean, if you know, okay, in the comment section below. Now you're about to. So this is true. Okay, so this is true. Now the acute angle. So acute. Okay, let me say acute. Okay, right angle, obtuse. Right. Okay, so the acute angle between P1 and P2 is 60. Okay, this you need to know this formula. So you have cos theta equals, okay, the cross product of this plus the product of this plus the product of this divided by the square root of the length of this of its respective length. Okay, as shown in this way in this calculation. So the cos theta equals half. So theta equals the arc cosine of 60 of half versus 6 degree. So again, C is true. How about D? So the equation of plane P is actually very straightforward. You already know. Okay, it also said if P3 is the plane passing through the point. So this is the point. And perpendicular. Perpendicular, I mean like this, okay? Perpendicular to the line of intersection of P1 and P2. So P1 and P2 intersect like this. The line of intersection means that is perpendicular in this way, right? Okay. Then the distance of the point 211 from the plane P3 is okay. You can easily find the equation of plane P3 by because you have known the ratio of the line intersection is like this. Okay, it is perpendicular. So yeah, it should be with the same ratio. So 1 by minus 1, 1. You just need to yeah, x minus x1, y minus y1, z minus z1. And you get the line equation, which is x minus y plus z equals 0. And the distance of 211 from this P3 is also straightforward. Okay, you just need to input it to the okay, the upper part. You can see this is x for 2, y for 1, and z for 1. So 2 minus 1 plus 1 all over square root of this actually the length of the line. Okay, so 1 1 1, so 2 by square root of 3. So this also true. So the correct answer for this is C and D. Okay, only C and D. Now physics. So a ring and a disc are initially at rest set beside the tall inclined plane, which makes an angle of 60 with the horizontal. They start to roll without slipping on the same instant of time along the shortest path. If the time difference between you reaching the ground is 2 minus square root of 3 over square root of 10 seconds, then the height of the top of the inclined plane in meters is, take g to be 10 meter per second square. Okay, so actually it is, you can derive the equation, the formula I mean, by yourself. I will not show the derivation for you. You can find it by yourself, or you can take it from any any literature or a book, a textbook. But actually, you should never try to memorize this. Okay, you should derive it, and it doesn't take very long time if you are already good at the basic of physics concepts, then it will not take a very long time for you to derive this one. So the the time taken for this to roll with the initial conditions at rest, okay, at the top on an inclined plane, okay, with theta, okay, the angle is theta, so it is roll without sleeping until reach the ground. It is expressed with this formula, okay. So 1 over sine theta times square root of, okay, you see this is the product of 2h over g and 1 plus IC is the moment inertia, and mr squared. Okay, so you can see for ring the moment inertia is mr squared, and for this the moment inertia is half mr squared. Okay, half times mr squared. So you just need to put it right, and then you just take the ratio. Oh no, because it actually asks you the difference, not the ratio. So this one's actually the same. You can just eliminate. You just factor out the h per g term, h over g term. You can just factor it out. So you just deal with this. Okay, so you have 4 minus 2 square root 3 like this by 3. Okay, oops, quite difficult sometimes. Yeah, you can see it is done as shown. Okay, and you get this is, yeah, blah 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 blah. Oh, you have been told before that the time difference is this. Oh, you are about to find the high. Okay, I see. So yeah, you just need a little algebra to deal with this, and you get the high is about 0.75 meters. Okay, 3/4, right? 3/4 meters. Okay. Now chemistry. Addition of excess aqueous ammonia to a pink color aqueous solution of M. M is not a real, right? Okay. So M here is any. I mean something, some element that we still doesn't know. That we still, yeah, we still don't know about. Okay. So MCl2 that. So this is hydrate, okay, 6H2O X and NH4. This is ammonium chloride, okay, gives an octahedral complex Y in the presence of air. In aqueous solution, the complex Y behaves as 1 by 3 electrolyte. The reaction of X with excess hydrochloric acid at room temperature results in the formation of blue color complex Z, and the calculated spin on the magnetic moment of X and Z is 3.87 bm, where it is 0 for complex Y. Among the following options, which statements are correct? So we have A, B, C, and D. Let's see. Actually, this is a quite complicated things. Okay. Um. So actually, we can analyze it. Okay, we can see clearly from the description, and we know that actually the M represents copper, cobalt. I mean cobalt. Okay. So you see, in aqueous solution. Okay. So we have aqueous solution and uh excess, okay, and H3 aqueous, yeah, this is aqueous. Okay, so yeah, you said and the ammonium chloride and the presence of air. Okay, also this is octahedral. Okay, so this is octahedral, and you see that you have the aqueous solution complex Y behave as 1 by 3 electrolyte. So 1 by 3. Okay, so this is 3, this is 1, right? Okay, so the reaction of X with excess of hydrochloric acid at room temperatures and the formation of blue colored complex Z. Okay, so you can see so in excess the excess of hydrochloric acid in the room temperature become this ion. This is the Z specimen. This is cobalt chloride ion. Okay, you can see, and for this is D2sp3 hybridization of central atom. Okay, so this NH3. Okay, so the ammonia is a strong field ligand. Okay, so we have three silver nitrate. Okay, so three silver chloride. Okay, so three of the silver chloride. Okay, yeah. Yeah, actually, it's a little complex thing. Okay, but yeah, after all, if you can, yeah, it is very clear from this. So this is this one. So Z is a tetrahedral complex. This one actually, this is a tetrahedral complex. So if you draw it, it become a tetrahedral complex. Tetrahedral means like this, yeah, something like this, tetrahedral. And when X and Z are incubated, the color of the switch is pink. Yeah, this one. Okay, so blue, if it reacts with water, so it becomes like this. Okay, so we have cobalt. Yeah, what is this? Okay, yeah, this one is pink. Okay, the equilibrium shifted towards X, making color of pink. This is also about direction. Okay, because yeah, tetrahedral. This is a blue field ligand. Yeah, yeah. So the solution will shift from blue to pink. Okay, so the correct answer is B, C, and D. These three. Okay, actually it's very straightforward. Okay, before I end this video, I want to share a quote for you. Okay, so George Eliot once said, "It's never too late to be what you might have been." Okay, I think that's the end of the video. That's the end of the video for today. Thanks for watching. Thanks for following so far. And here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with exploits.unaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful.